have a confession. You're doing way better at math than you think you are. So good, in fact, that if you stick around for the next few minutes, you're going to see for yourself that you'll be able to solve composite functions like an all-star, even if you've never seen them before. Let's get started. Hey everyone, Dave here. I'm sure you've seen things like f of x or g of x, your typical functions. In this case here, with what I wrote down, you may have not seen this notation before. And if it's your first time, that's okay. This is what we call a composite function. In this example, x is not the input to your function f of x, but it's actually a function that's an input, the function g of x. When you see something in your homework or exam written this way, the way it's pronounced is f of g of x instead of simply f of x. Okay, so that's a composite function, but why on earth do we care about them? And that's a fair question to ask. I'll give you a real-world usage of this. Say, for example, you had a function for driving a car that tells you the stopping distance of how far your car travels is a function of how fast you've been driving. Let's call that f of x. And then let's also talk about how your engine generates heat. And say that's a function g of x that depends on a bunch of other things, such as the temperature outside, how fast you are driving, how fast you're braking, etc. An example of a composite function can be used here, where if you take a function for stopping distance and another function for heat, what if we want to make a relationship directly between the heat that you produce and how far you stopped? This is where a composite function has a real-world example. Okay, so enough of that. Let's get into how we actually evaluate these expressions. And before I get there, if you haven't already, hit that subscribe button for me and feel free to leave a comment. Tell me what kind of content you'd like to see on this channel and any struggles you've been having with pre-calc. The way I like to think of composite functions in a visual way is to draw a train with boxcars. In this example here that I've drawn, we're going to start with the very left of the train. You have this box that's labeled as the g function. And I want you to take a look at the original notation I wrote above, f of g of x. This train is drawn in such a way that when you start from the very left, we always start with the inner function. When you have the expression f of g of x, the innermost function is going to be g of x. And when I see a composite function, the way I think about this is, which function is in the most parentheses? In this case, g of x is surrounded by outer parentheses, right? And it doesn't matter how many composite functions you have. If I had f of g of h of x, the innermost function would be h of x. And the outermost function in that example and this example would be f of x. So with this boxcar situation, what we do is we start with the innermost function, and when we're given a value of x, say x equals 5, we always start with evaluating the inner function first. And then what's going to happen is you're going to take the output of the inner function, and that numerical value will then be provided as input to the outer function. So for example, for f of g of x, when you're given a value of x, we solve that value of g of x provided the value of x is given to us, and the output of g of x will be a number. Plug that into f of x, and you'll get your answer. And so if we have an example problem to solve, say for example we have f of x equals x squared, g of x equals 2x plus 1, and we want to solve the expression f of g of 2. Going back to the boxcar, we start on the very left-hand side. The very first step we begin with is evaluating the g of x function, which is 2x plus 1, by plugging in that value of x, which is 2. And then the resulting output of that would be applied to f of x. So now giving this a try, g of 2 is going to be 2x plus 1 being evaluated with the value of x equating to 2. And that's going to give us 2 times 2 plus 1, which is 5. We now take this value of 5 and plug it into f of x, which is x squared, resulting in 5 squared and a final answer of 25. One thing that's really important here as well, I wrote this as f of g of x, correct? What if I wrote the problem as g of f of x instead? How would you solve this? Well, the same concept applies. The only difference here now is your inner function happens to be f of x in this case. So you would basically work from the inside out as before, solve the inner function f of x by plugging in the value of x directly into that function, and whatever output you get, feed it to g of x. I wanted to point that out because sometimes on a homework or an exam question, you might be tricked. You're so used to things being written as f of g of x, but your teacher might throw a curveball at you to make sure you understand the concept. So I hope you enjoyed this video. Be sure to check out this playlist for more pre-calc help, and I'll catch you later.